This video focuses on overview of relational model. Relational model doesn't have a standard graphical representation and is simply a set of tuples, which is why it's used for logical internal modeling and not conceptual modeling. It is used to build out logical and internal data models and is represented as a collection of relations, which is basically a table of values or entity types. In a relational model, entity type is relation, entity is a tuple, attribute type is a column name, and attribute is a cell if you're comparing it to a conceptual model sets like EER model. Let's talk about the domains when it comes to relations in a relational model. Domains are values for an attribute types, and they can be specified as what is admissible. For example, for relation billing with attribute types producer name, producer number, quantity of products, we can specify the quantity portion of it to have a specific value by adding range to it in a relational model. Cartesian product specifies the combination of domains in a multiple relation and will list all possible combinations, and the new relation will then be a subset. Critical thing to note about its domain is its constraint, which states that the value of each attribute type must be atomic and single value. This is going to be tied to first normalization form, which we'll talk about in a later video. Critical concept and fundamental building block in a relational model is keys, which are what is used to not only uniquely identify all the tuples, but to create relationships as well. Key constraint specifies that every relation must have one key to ensure tuples are uniquely identified. Note that relation is made up of multiple tuples, which means all tuples has to be somewhat distinct. This is why you need to have a unique key to identify the tuples and to create relationships. Note that relation is made up of multiple tuples, which means the tuples have to be distinct to tell from one another. This is why you need unique keys to identify the tuples and to create relationships. First term we have is superkey, which is a subset of attribute types that states no two tuples in any relation state should have the same combination of values. If there are more than one key, then the keys will be considered candidate key, with one being assigned as primary and the other being as alternative. Primary key identifies tuples in the relation in a unique way and establishes connections or associations to other relations by becoming the foreign key in other relation. An alternative key is pretty much alternative to the primary key. Primary key should always satisfy a rule of not being a not null constraint, because if it is null, it won't be able to uniquely identify a tuple. The rule of satisfying a not null constraint is called entity integrity constraint. Alternative keys can be defined to have not null or null constraint. Foreign key is a way to establish a connection between relations, but it must meet a condition called referential integrity constraint, which states that foreign key must have the same domain as the primary key attribute types it is referred to, and also it needs to occur as a value of either null or primary key value. There are two ways to utilize foreign keys. In a relationship that is not NM, you can use one foreign key in another relation, while in an NM relationship, you will need to create a new relation and utilize two foreign keys that will become the primary key in a new relation. In an NM relationship type, it will create multi-value attribute type in both ways, so you can utilize a foreign key in another relation and vice versa. Primary keys in a relational model are underlined and foreign keys are in italics. So we talked about 4 different relational constraints so far: domain key, entity integrity, and referential integrity. Domain constraint basically states that attribute type's value must be single and atomic. Key constraint basically states that every relation should have a key to uniquely identify its tuples, like the primary key. In an entity integrity constraint, attributes that make up the primary key shouldn't be null, which basically supports the key constraint. Then we have the referential integrity constraint that focuses on the foreign key. The foreign key in a referential integrity constraint should have the same domain as the primary key it is associated with and should occur as a value of either primary key itself or show as null.